In this video, I'm going to show you how to find the gradient of a function where it's given with x as its subject. We use a special case of the chain rule for this. We still need to find dy by dx, but we use the fact that dy by dx multiplied by dx by dy equals 1. So we can find dy by dx just by the reciprocal of dx by dy. And that's how we proceed with this kind of example. Okay, so let's look at a couple of examples. Right, the first one, we've got x is 2y to the 4 minus 5. So we start off by finding dx by dy. So we've got 8y cubed only. 5 obviously disappears when we differentiate it. So dy by dx is just going to be 1 over 8y cubed. Okay, second one. Okay, this one, we start off the same. Obviously, we're going to think of this as 8y to the half when we differentiate it. So dx by dy is going to be 20y to the power of 4. This is y to the half now, so minus 4y to the minus a half. Now, we could just write 1 over that, but it would look pretty horrible in mathematical terms. So what we're going to do is factorise this first before we turn it upside down. So clearly we can take a 4 out, and then we're going to have 5y to the 4 minus, I'm going to write this as 1 over the square root of y. It's power of minus a half. Okay, so now we're also going to take out the root y as a factor. So we're going to have 4 over root y. The second term we can simply write as minus 1, that's nice and easy. The other term, now we've taken out a factor of y to the half, so we need to multiply by y to the half. So we're going to have 5y to the 4 plus a half, so to the 9 over 2. Okay, so now we've got that as a factorised term, we can then turn it over upside down to get dy by dx. So dy by dx is going to be, the root y is going to go on the top, because that was the denominator, and we're just going to have 4 lots of 5y to the 9 over 2 minus 1 on the bottom. Okay, one more of these. Okay, trig one this time. So we've got x is minus a sixth cot 3y. So hopefully you remember the differential of cot of x. So we've got dx by dy is going to be minus a sixth cosec squared of 3y, and then we've got to multiply by the differential of 3y, which is just 3. So our 3 will cancel with the minus 6 to give us a minus a half cosec squared of 3y. Okay, now we could write that, oops, just realised I've made a mistake and I've missed my minus out here. Okay, sorry, so the minuses cancel out and we get a plus there. Okay, so we've actually, cosec is 1 over sine, so we've got 1 over 2 sine squared of 3y. Okay, so if we want dy by dx, we've just got 1 over that, so we've got 2 sine squared of 3y. Okay, so obviously we can apply simple problems like this one. Find the equation of the tangent of x equals y squared at the point 1, 1. Okay, so dx by dy is going to be 2y. So dy by dx will be 1 over 2y. Okay. At the point we're interested in, so at the point 1, 1, dy by dx is going to be 1 over 2 lots of y is 1, so it's going to be a half. So then we just use our equation for the straight line. So we've got a half of x minus x1 equals y minus y1. Multiply through by 2, so x minus 1 is 2y minus 2, and 2y is x. Bring the plus 2, the 2 across, and plus 1. Okay. One more. This time we've got to find the equation of the normal. So we start off by finding dy by dx. We've already done this bit actually, but dx by dy is 2y, so dy by dx is 1 over 2y. So at the point 16,4, dy by dx is going to be 1 over 2y, so 1 over 8. So the gradient of the tangent would be an eighth, so the gradient of the normal will be negative the reciprocal of that, so it's going to be minus 8. Okay, so then to find the equation of the normal, we'll have the gradient x minus x1 is y minus y1. Okay, so minus 8x minus 100 plus 128 is y minus 4. So y plus 8x equals 132.